But I want to talk to you guys about lesson 1-1. We're going to kind of go backwards a little bit here to some simpler times. Lesson 1-1 is on linear topics. I'm going to be honest with you here. I expect that a lot of these ideas that you're good with, and so I'm not going to bore you. I'm not going to talk about stuff you already know. I'm going to mention a couple things just to refresh your memory. I'm going to do a few examples, but a lot of this is just to say, make sure you can do this. And if you're like, I can't, or I need some more help, just ask. You're not the first person. One of the things the book likes to do in section 1-1 is talk about an increment. And now I'm picking out some things that, are basically probably require a little extra going over. So this might be something that you say, oh, I didn't realize that. So an increment mathematically is a coordinate movement. It's a coordinate movement. Now I'm kind of purposely using some fancy words here, but it's actually referring to something quite simple. It's just referring to how far did you move on the x and how far did you move on the y. Because a coordinate is x or y. And so we're just kind of asking how much did I move left and right and how much did I move up and down. For maybe something like this. I'm going to write this out. You don't need to write out all the words if you don't want to. It's your notes. But what if I asked you to find the increment between 4, -3 to 2, 5? So we're going to find the increment between 4, -3 and 2, 5. Now, because it's a coordinate movement, we have to split it. We have to split it to be the x coordinate or the delta x, the change in x. And something good to remember when we talk about any type of change is always to subtract the right way. If I went from 4 to 2, everyone in this room knows that if I went from 4 to 2, I went backwards. But if you subtract the right way, you'll be able to say that. You'll be able to get that result. So you always subtract the second minus the first. You always subtract the last minus the first. So 2 minus 4. And of course, it says that I went backwards. I went backwards too. That's the increment for x. I would say make sure you take a moment and think about the increment for y. What is the movement? Okay, and if you subtract the right way, that is the second minus the first, that is 5 minus -3. Okay, so it works. It comes out to be +8, and indeed it should, because we went from -3 to 5. So that means, again, you moved 8. Okay, now these are linear movements. I know you know this. In fact, change in y, change in x. Okay, what we really did was we just broke down the slope. And so, of course, we could find that if that was asked. How about this conversation about equations? Okay, when we talk about linear relations, there's certainly equations that speak of that. And of course, they're going to be equations of lines, since we're talking about linear relations. Now, just for a complete list, I'd be remiss if I didn't say y equals mx plus b. And I know you know all about that, and indeed you should. So y equals mx plus b. How about something that I'm sure you've seen, but maybe just needs a little refresher? Okay, now when you see an equation of the form ax plus by equals c, so ax plus by equals c, we would say that that is, and it depends on kind of the teacher of the book, but we would say that that is general or standard form. So that's general or standard form. Now make sure you realize that that's just a little different arrangement of x and y. It's just a little different arrangement. It does not give the slope, but it could be rearranged to do that. And the thing about general standard form is that it uses certain kinds of numbers. I want to make sure I get this right. Probably the most popular thing about this is the fact that a and b are always going to be non-fractions. A and b are going to be non-fractions. The other thing about a and b is that both cannot be equal to 0. So basically, they're never going to be fractions. They're also not going to be equal to 0, or I should say both of them can't. One of them could equal 0 officially. Okay, one of them could equal 0, but not both at the same time. The other thing about standard form is that the leading coefficient always has to be positive. Always has to be positive. Honestly, we could put the word always on any of these statements. Now, I know this isn't the most exciting stuff ever, but if you're asked to get an equation in standard form, you got to make sure that this stuff's happening. So if one of these is a fraction, make sure you multiply through by the denominator. If this guy's negative, if a is negative, make sure you switch the signs. You know you can change things, so you have to change it to make it standard. I'm going to show this, but I expect that you know this. That is, if you have an equation of the form just y equals c, now that implies that there's no x, so it's just y equals a number. That's a horizontal line. And of course, if you have an equation of the form x equals d, well, of course, that's a vertical line. I do expect that you know that, but it kind of makes a little more of a complete list just to see it again. All of those are equations of lines. Now remember, the reason that they're lines, or maybe I should say the reason that they're linear, is because of their degree. Their degree. Remember, that's sort of a math term that is referring to the exponent. Every exponent on the board right now is 1. So when you have degree 1, you're talking about this kind of stuff. Okay, of course, there's other degrees, degree 2, degree 3. But just remember what makes it linear. Now, when you come back, we're going to do something on your calculator, which is also part of this lesson. I just don't want to start it because it'll be better not to break it up. So we're going to do something on your calculator. If you have a book, you can have it handy. If you don't, you might just have to listen more, or maybe a friend has one you can take a picture of.